Welcome back on the Space Info podcast. Here we talk about space and everything related to it. If you are passionate about space, astronomy, technology and everything about it, you can join all our social platforms at the Space Info Club or our website at www.spaceinfo.club, where tons of content and a community of experts are there waiting for you. This is the Space Info Club. Today we talk about ozone, and particularly the ozone layer, from crisis to recovery. Because the Earth's ozone layer is a crucial shield against the sun's harmful ultraviolet radiation, faced a great threat in the 1980s when the discovery of a gaping hole above Antarctica sent shockwaves through the scientific community. However, the international cooperation spurred by this alarming revelation has led to significant strides in protecting and repairing this vital layer of our atmosphere. Today, as we mark the International Day for the Preservation of the Ozone Layer, it's essential to reflect on the journey from crisis to recovery and the lesson that we have learned across and along the way. But what is ozone? Well, this is particularly a molecule composed of 3 oxygen atoms, which serves as a crucial protector in the delicate balance of the Earth's atmosphere. It's colorless and it's a gas and plays a fundamental role in safeguarding our life on the planet by filtering harmful ultraviolet radiation from the sun. It's present high above us in the stratosphere, forms a layer that shields against the detrimental effects of excessive ultraviolet exposures. So today we'll talk about the significance of ozone, exploring the properties, formation and the profound implications of its depletions. So, which are the properties of this gas? Well, in its distinct odor and pale blue color, it's a highly reactive gas. Indeed, it occurs naturally in the atmosphere, predominantly in the stratosphere, although it can also be found at lower altitudes near Earth's surface. Its molecular structure, consisting of 3 oxygen atoms, gives it unique properties, making it both beneficial and potentially harmful. One of the most significant characteristics of ozone is its ability to absorb ultraviolet radiation from the sun. When ultraviolet rays interact with the ozone molecule, they undergo a process of absorption and dissociation, converting the high-energy ultraviolet radiation into heat. This process effectively shields the Earth's surface from the majority of ultraviolet radiation, thereby protecting the life from the adverse effects of exposures. But how is ozone formed? Well, the formation of ozone primarily occurs in the stratosphere, where the oxygen molecule, which have only 2 atoms of oxygen, are broken apart by solar radiation, which is the energy counterpart in the process. This process indeed is known as photolysis, resulting in the formation of high reactive oxygen atom, so singular atom freely moving to the atmosphere. Subsequently, this oxygen atom combine with molecular oxygen and form ozone, so we end up with the molecule of 3 atoms of oxygen, to resist of obviously chemical reaction. So the ozone layer is located approximately from 10 to 30 kilometers above the Earth's surface, and here is where we have the highest concentration of ozone. This layer is active as a barrier basically, and is absorbing a significant portion of incoming ultraviolet radiation before reaching the surface of Earth. But why is this important? Well, the significance of ozone cannot be overstated, as it plays a critical role in maintaining the delicate balance of our planet's atmosphere. Without the protective shield provided by the ozone layer, life on Earth would be exposed to harmful levels of ultraviolet radiation, leading to a myriad of detrimental consequences. One of the most immediate impacts of ozone depletion is its effect on human health. Excessive exposure to ultraviolet radiation can result in various health issues, including skin cancer, cataracts, and immune depression. Furthermore, ultraviolet radiation can also cause damage to ecosystems, disrupting the delicate balance of terrestrial and aquatic environments. In addition to its role protecting human health and environment, ozone also plays a crucial role in regulating atmospheric temperature. By absorbing ultraviolet radiation and converting into heat, ozone helps to warm up the stratosphere, contributing to the stability of Earth's climate system. Wait. Wait a minute, maybe it's the first time you're listening to the Space Info podcast. So I have to let you know that spaceinfo.club is a platform and a community. We are today counting more than 130,000 followers and members across all the different platforms. So I strongly invite you to visit our website at www.spaceinfo.club to discover all the content we publish, and also our Instagram account and LinkedIn profile. If you're a company or a professional who would like to be featured on our platform, don't hesitate to contact us, so you'll be featured on our magazine, articles, and also can participate in the Space Info podcast. Now, back to the episode. Maybe you have listened to warming up the stratosphere, but be careful. Stratosphere is a layer of the whole atmosphere, so ozone is preventing the warming up of the whole atmosphere by absorbing this heat coming from the ultraviolet and overall radiation from the sun. But now we'll talk about the depletion of the ozone layer, because despite its critical importance, the ozone layer faces a significant threat from human activities, particularly the use of certain chemicals such as CFCs, so chlorofluorocarbons and halogens, has been identified as the primary cause of ozone depletion. So these chemicals, once released into the atmosphere, undergo a chemical reaction that releases chlorine and bromine atoms, which then catalyze the breakdown of ozone molecule. Well, do you remember when we talked about the formation of this molecule? You can imagine this process as the inversion of that first process of forming. Now we are disrupting the ozone molecule. So the most notable consequence of ozone depletion is the formation of the ozone hole, a particularly seasonal thinning of the ozone layer over Antarctica, which was firstly observed in 1980s, and the ozone hole serves as a stark reminder of the detrimental effect of human activities on Earth's atmosphere. But why this hole is forming almost exactly over Antarctica? Well, because the atmosphere of our planet is not static. You have winds, difference in pressure between regions of the Earth, so basically a lot of currents and winds themselves form along all the surface of Earth and inside the atmosphere, particularly into the troposphere. So particularly circulation of air basically draws the atmosphere and the concentration of ozone all over the planet, but there is a particularly unconcentration of this molecule over Antarctica, and this led to the formation of the ozone hole. Indeed, we say that in the 1980s we have saw the emergence of a significant environmental concern, which is indeed the ozone hole, as said primarily above Antarctica. Well, this all resulted from the release of ozone-depleting substances, as we have said, the CFCs, aerosol cans, air conditioning units, and refrigerators. So scientists started warning that unchecked depletion of the ozone hole and ozone layer particularly could have catastrophic consequences. So, in response to the ozone layer perilous condition, the international community rallied together, culminating in the signing of the Montreal Protocol in 1987. This landmark agreement aimed to phase out the production and use of ozone-depleting substances, heralding a new era of environmental stewardship. Remarkably, the Montreal Protocol stands as the only United Nations treaty universally ratified by all 198 member states. Decades of concentrated efforts have yielded promising results in ozone layer recovery. Scientific observation confirmed that a steady decrease in the size of the ozone hole, with recent reports indicating significant shrinkage. The depletion of advanced monitoring technologies and stringent regulations on ozone-depleting substances has been instrumental in driving this positive trend. So, projections suggest that with continued adherence to the Montreal Protocol, the ozone layer could fully recover by 2050, so we still have 25 years from now. Such a feat underscores the efficacy of international cooperation in addressing global environmental challenges. Moreover, the success story of ozone layer recovery serves as a beacon of hope and inspiration to the fight against climate change. Klaus Zerrer, the mission manager of European Space Agency Copernicus Sentinel-5P, highlighted a remarkable occurrence in 2019, a record-breaking reduction in the size and duration of the ozone hole. This anomaly, Zerrer explained, was attributed to a warming of the the stratosphere or the South Pole. However, Zen cautioned against misconstruing this event as an indication of an accelerated global ozone recovery. The stratosphere experiences significant fluctuation in temperature and polar vortices, which directly influence the size of ozone hole. In the case of 2019, the warmer conditions in the polar stratosphere resulted in the deceleration of wind fields. Do you remember what we said? Around the South Pole, known as the polar vortex. This slowdown impeded the formation of polar stratospheric clouds, which are crucial for the chemical reaction leading to rapid ozone depletion. Echoing Zen's sentiments, Joseph Ashbacher, who is the ESA's Director General, underscored the pivotal role of scientific evidence in driving policy changes and behavioral shifts. The discovery of the ozone hole in the 1970s-1980s prompted continuous monitoring efforts utilizing space-based in situ devices. So now we can just note that the combination of space segments and ground segments in the observation is of paramount importance. This vigilance culminated in the Montreal Protocol, as we said, of the 1980s, which banned the use of ozone-depleting substances like CFC. Again, Ashbacher emphasized the success story of the ozone layer recovery, attributing it to decisive political action. He framed the ozone hole's trajectory as a beacon of hope and a model for addressing climate change. Indeed, the collaborative efforts, spurred by scientific insights and international cooperation, offer valuable lessons tackling environmental changes head-on. So to conclude this episode, we can say that ozone stands as a critical component to Earth's atmosphere, providing essential protection against harmful effects of ultraviolet radiation. Its role in safeguarding human health, preserving ecosystems, and regulating climate underscores the importance of preserving the integrity of the ozone layer. By addressing the root causes of ozone depletion and continuing to uphold the international agreements such as the Montreal Protocol, we can ensure a sustainable future for future generations. So, as you can see, collaboration, international cooperation are the key to a success of a global project. But that's all for today. I hope to see you in the next episode of the Space Info podcast.